I'm Melissa.
And I'm Jam.
And I'm a chemist.
I'm not.
And welcome to Chemistry for Your Life,
The podcast up to understand the chemistry of your everyday life.
Jam, are you ready?
I think so. What am I getting myself into?
You're getting yourself into rust.
Ooh, that sounds gross. Maybe if I could not literally get into the rust in any way or I touch it, but if it's just more like getting into the topic, then yes, then I'm in.
That's what you're doing. You're getting into the topic.
Okay, sweet. I'm in. I'm back on.
Okay, so last week we talked about cast iron pans.
Right. Which was awesome.
That was awesome, and I hope all of you are now believers. But one big thing with cast iron pans, what we're protecting them from, all that stuff is for keeping it from rusting.
Mm.
And while I was doing all that research on cast iron pans, a question came back into my mind from the deep, deep caverns. One time I was hanging out in my garage with, I live with a married couple, so the husband was working on his bike, and he said, "Hey, why does vinegar remove rust?" And I was like, "That's a great question." And then I never did anything at all with it. So it resurfaced in my mind, and then I asked myself, what even really is rust?
Yeah.
So that's what we're going to talk about today. So my question for you is, what do you know about rust? What do you think it is?
Man, okay. That's such a great question. I think in my brain I've heard we always think of it as when iron is exposed to water, but isn't it really more like oxygen is what has the effect on the iron creates rust? I don't know what you'd call that, like what the actual then material is, if it's iron oxide or something like that.
Mm-hmm.
But that's what I've heard, that somehow the water allows, just leaving it in the open air, it doesn't do that even though there's oxygen around. But for some reason the water does it. But I've never heard why. If I did, I forgot.
Great. That's good.
Any of that close?
That's all really close. And I think you have heard about it probably when you took chemistry with Miss Pittard, because you should have learned this in first semester, maybe second semester, general chemistry.
Okay, sweet. That sounds right. It seems like the kind of thing that we would go over and that I would forget.
I asked one of my friends, do you know what rust is? And they said, isn't it just oxidized iron? So similar to what you said.
Uh-huh.
But the question is, what is oxidized iron? How does that happen? Why does oxygen sometimes have an effect and sometimes not? And what does water have to do with it, right?
Right. And oxygen's supposed to be good. Why is it messing with our iron? You know what I'm saying?
Okay, well, I'll tell you. So what happens when your iron rusts is actually known as a redox reaction.
Okay.
Redox reaction is actually the combination of two reactions. One is a reduction reaction, and one is an oxidation reaction. So they combine those two words to make it redox.
Oh, gotcha.
Redox reaction. Reduction plus oxidation, redox. So both of those are happening at once.
Okay.
And the most basic definition I can give you of a redox reaction is it's just shuffling electrons around to make new things.
Huh.
So remember when we talked about atoms, they have a core center made up of protons and neutrons. And that is surrounded by areas where electrons are likely to be in them moving around.
Right.
You're tracking with me?
Yes.
So a redox reaction, all that happens is electrons move from one element or atom over to another atom.
Okay.
That's the basics of it.
Okay.
So when your metal rusts, your iron is losing electrons and the oxygen is stealing electrons. Okay. That's it. That's what happens. But I'm going to talk to you about the names for those.
Okay.
Because they're kind of confusing. So when something gains electrons, it's known as being reduced.
Because electrons are negative?
Yes, good
Okay.
job. So it's weird to think of gaining as reducing, and I mess that up a lot.
Yeah, that's like really counterintuitive. It reminds me of like when you learn how to subtract and add with negative numbers.
Oh, yeah.
Plus -50. And it's like, I mean, can we just say -50? Like,
So it's like that for sure. And I always have to remember by this mnemonic device they give you where they say oil rig. So oxidation is losing electrons. Reduction is gaining electrons. So it's really counterintuitive to think of reduction as gaining, but it's because of the charge. The charge is being reduced. So electrons are negative, it's being reduced. Actually, the oxygen in this reaction is being reduced. The oxygen gains electrons, and the metal gives up electrons to the oxygen. So that's why we call the metal being oxidized.
Got it.
The oxygen is acting, so it's oxidized. Does that make sense?
Yeah, it does so far.
Okay, so that doesn't happen spontaneously, right?
Right.
Because you leave metal in the air and nothing happens.
Yeah, which like that's definitely the most perplexing part to me. I mean, I guess I'm not gonna understand every other part, but it is like one of the first questions that comes to mind.
So a lot of times electrons need something to move around in.
Okay.
So in the case of this particular redox reaction, there usually is some kind of an electrolyte solution. Do you know what an electrolyte is?
Not really. I don't think.
An electrolyte is essentially just atoms that have gained or lost electrons that are floating around in a solution. So it's known as ions. So an electrolyte solution is just a solution with ions or electrolytes floating around in it.
Okay.
So in redox reactions, to get the electrons to flow from whatever is losing electrons to whatever is gaining electrons, you need some kind of electrolyte solution. In our case, water is that electrolyte solution.
Okay.
Because water, although you might think of it as just H2O molecules floating around, has tons of other stuff in it. It always, pretty much, in its naturally, however you're going to encounter it, has ions floating around in there.
Got it.
So leaving water on your cast iron pan and then exposing it to oxygen means that those electrolytes dissolved in your drinking water are going to allow electrons to flow from the pan to the oxygen. So the iron will be oxidized and the oxygen will be reduced. The iron loses electrons and the oxygen gains electrons.
Okay.
And when that happens, then your iron is a positive charge, your oxygen is a negative charge, and then the two come together to make rust, iron oxide. So iron oxide is actually an iron ion that's lost electrons plus oxygen ion that's gained electrons coming together to make a pair. Just like how sodium chloride is a sodium ion, chlorine ion come together to make a pair.
Interesting. So once the oxygen gains the electrons, it's kind of like it stole something from the iron, and then it's like, but hey, want to still be friends?
Right. That's kind of how ionic bonds are. So ionic bonds are one atom steals an electron from another, and then they hang out close together. So in salt and chlorine, in table salt, sodium and chlorine, sodium has lost an electron, chlorine has gained one, and they just hang out together.
Interesting.
And so iron oxide just kind of is that same way, where there's a redox reaction where the iron, pure elemental iron, loses those electrons. They go over to oxygen, and then now one's positive, one's negative, and they, boom, hang out together to cancel each other out.
Interesting.
Mm-hmm.
Wow.
And that's how rust forms. That's what rust is.
Weird.
And are you ready for this?
Yes, I'm ready.
That same reaction is what runs a lot of batteries.
Where it's stealing, like, one thing is losing electrons and another thing is gaining them.
Mm-hmm. The redox reaction is part of what runs batteries. And that reaction is the reason the Statue of Liberty is green.
Oh.
Because the Statue of Liberty is made out of copper and copper oxidized to give you that green color.
It's so weird that its color ends up being like that.
I know. That instead of just being the same color as metal or whatever, it's rusty red or that nice green. Mm-hmm.
It's so weird. I wonder if it was like, oh, dang, we didn't think about this. It's supposed to be this, like, shiny bronze kind of thing, and then copper-looking color, and then it's like, oh, it's green?
I kind of like it.
And then it's like, well, it's too late. We built a whole island for it, so can't do anything about it.
Can't do anything about it. Now we just got to look at that pretty green Lady Liberty. All that thanks to redox reactions.
Interesting. Dude, that's really weird.
It is really weird.
Okay. I think I can do this. Ready for me to try to say it back?
I'm ready for you to try to say it back. And once you do say it back, I have 2 more fun facts for you.
Dude, I love the fun fact thing. It kind of like helps me look forward to and be encouraged about attempting to say this back to you. It's like, well, either way, there's some cool tidbits waiting for me at the finish line.
There's cool tidbits. One has to do with the reaction itself, and one has to do with the answer to Ryan's question.
Okay, sweet. Oh, about vinegar?
Mm-hmm.
Oh, nice. Okay, cool. Okay, so iron has electrons.
Yep. That's a safe bet for most elements.
All right, I think I nailed it. We can move on then.
The one thing is hydrogen has 1 electron, so it wouldn't work for that statement.
Nice. So the odds were definitely in my favor on that statement there.
Definitely, yeah.
And oxygen in general would want its electrons. Like, if it could have them at all the time, it would just want them.
Yeah,
so
oxygen's going to come around and scavenge up electrons.
Just the kind of guy oxygen is. And so
I think, although I can't be sure, this is a bold statement for me to make. This is off the cuff. So if I'm wrong, this is just what I think.
Uh-huh.
But I think it has to do with the fact that oxygen exists as 2 radicals, which we talked about in the antioxidants episode. And I don't know that for sure. And that's just my guess as a chemist and with the information that I know, that's why oxygen is kind of scavengy and it likes to steal 2 electrons, 1 for each radical. That's my guess. I did not confirm that anywhere before I said it, but with the knowledge that I have, that's what I think.
Interesting. Chemistry controversy.
Making bold statements.
So it wants the electrons, but most of the time, oxygen can't get at iron's electrons. You got your pan, it's just sitting in a drawer, or it's sitting out on the counter or whatever. There's oxygen all around, but it can't just get at iron's electrons.
That's exactly right.
You put some water into the mix or anything with the electrolyte solution, like property to it, that could allow, and has oxygen, I guess, that can allow the transfer of electrons through it, kind of like the highway thing we talked about the other day, or like a bridge, basically something that allows now these 2 different things to interact, and then electrons can go back and forth across it if they would like to.
Yes, bridge is a great analogy.
So now these oxygens have the connection that they need to go over to their neighbor's iron and ask for a cup of sugar or ask for their electrons or really just take them. And it takes the electrons from the iron, and then they, in a weird twist, are friends.
Right.
And
that's right. Yeah.
decide to hang out really close to each other, making iron oxide or rust.
Right. Because one's negative and one's positive.
Yeah. Right. And we've talked about like negative and positive things liking each other, and a lot of different things that have worked well for like a magnet kind of analogy. And so they become like some little magnet buddies, I guess, where somehow iron's doesn't seem to be bothered by the fact that oxygen just stole something from him. But, we all have friends.
Perfect.
We all have friends like that, I think,
Oh, definitely. We all have friends who steal our stuff and then become our best friends. It's like, now you have the thing that I need because you stole it from me, so I'm going to come hang out with you.
Your friend borrows a book of yours, and you're like, well, I'm not sure if I want to be friends with this person forever, but I at least have to ride out our friendship until I can get my book back.
But really, in ionic bonds, everyone is happy and stable. Because this reaction occurs naturally. You don't have to put energy in to make that happen. It's going to happen as long as there's iron, water, and oxygen together. So really, somehow, it's as if iron wanted its friend to steal its stuff.
That's interesting. We just think of it as bad because to us, it's not good. We don't want rust in our food and stuff like that.
Right. Definitely not. Or on most of our metals.
Yeah. But it's funny to think that it's not really truly bad from the point of view of the elements.
Right. The elements are stable that way. More stable, in fact, than as pure iron.
So they just don't really care about us, I guess, is what you're saying. They're not that worried about what we're trying to cook or do or whatever.
That's right.
Huh.
Are you ready for your fun facts?
Oh, I'm very ready, please.
Okay, so we have 2 fun facts, and then I'm going to go a little crazy and do a listener question.
Oh, okay.
I mentioned this episode to real life friend and listener Mason K and got a question out of that as well.
Nice.
Okay, so.
Did you put him in his place a little bit, though, just to make sure he knows he can't just ask questions whenever he wants?
Yeah, I said, I already have that in here.
And then maybe we could be like, okay, this one time, but next time, no. Or we'll see. Something like that. I'll let you decide.
We love listener questions. So any listener question at any time, I will happily take.
That's true. It does make it fun. That's why we have a whole episode dedicated to them. It's like...
That's so true. But it just goes really well with what I was going to already say here. So it's perfect.
Perfect.
So what we need in the water is not the water itself. It's all of the electrolytes dissolved in the water, right?
Right.
So that means, theoretically, if you could get perfectly pure water with no electrolytes in it at all, your stuff wouldn't rust.
Oh, weird.
But it would be very hard to get that, especially on a pan or in any environment where iron naturally is. There's probably even salt electrolytes of some kind on the metal itself, just hanging out from life. So it'd be very difficult.
Yeah, that's crazy. So with distilled water, they're just really taking out like all the dissolved solids and stuff like that, right?
Distillation is evaporating water, having it collect and cool back down from steam. So a lot of stuff has been left behind, but I don't think it's possible unless you're in a sterile environment for absolutely nothing to be dissolved in that water. But it does have less. So the electrons won't flow as efficiently. So distilled water would probably rust slower. Which brings us around to Mason K's question, which was, I've heard that things rust more quickly around the coast. That's because there's a lot of salt water around the coast, and it has a lot more electrolytes dissolved in it, which means electrons can flow way more easily.
Yeah, I've known that because you gotta like keep an eye on your car because just the underside of your car and different parts of it can rust way easier if you live on the coast, stuff like that. That's much more of a challenge they have to work out, like they have to look out for. That reminds me, do you know why they call it distilled water?
I know that it's because it's been distilled, but I feel like you have a dumb joke coming, but I can't figure out what it's going to be.
So they take a lot of...
Okay, lay it on me.
They take a lot of stuff out of it. And when they're first doing that, they took tons of stuff out of it and then took a sip and then they're like, distilled water.
No.
It's kind of different, but distilled water.
I knew something was coming, but I could not figure out what it was.
So that's why they call it that. Just like,
So, oh gosh, that's not why they call it that. Just for the listeners at home, we don't want you to be confused by Jam's crazy pun.
Sorry, guys.
So that's one fun fact. If you took all the salt out of water, theoretically, if you could get that somehow, you wouldn't really be able to rest.
Huh. Man, that's crazy to think about.
And on the opposite side, if you put a lot more salt into your water, it rusts much more quickly. So that's one fun fact.
Yeah. That's crazy. I would not have thought about that.
But isn't it kind of fun?
Yeah. Oh, yeah, for sure. Unless you're on the side where there's way more salt around, and then it could be less fun for you.
That's true. My sister lives on the coast, and I think it has impacted her vehicles.
Oh, dang.
So now let's have fun fact number 2.
Okay.
Originally, Ryan's question was, why does vinegar remove rust?
Mm-hmm.
So the answer to that question is that acid reacts with rust and just dissolves it, turns it into a salt plus water, and that rinses it away. So I think sometimes people think that it reverses the rust reaction, but it doesn't. It just removes the rust. It forms depending on your acid. So if you have HCl, which is not one that a lot of us have around our homes,
right?
It makes iron chloride and H2O. Takes the iron, pairs it with the chlorine from HCl, hydrochloric acid, and makes FeCl, and then the oxygen from the iron oxide, which is the rust, plus the hydrogens from the acid makes water.
Interesting. So you are still losing that iron, a little bit of it.
Well, you're losing the iron oxide. The iron that had rusted away, you're basically just rinsing that off by making it into a new compound and washing it away.
Yeah. So like there's some amount of your pan that is gone. It's like it put it back into the pan or whatever. Got it.
And so with vinegar, which is a very, very dilute acid, it does that. But if you were to take the super concentrated form of the acid and pour it on your rusty thing, it would actually also react with the metal and dissolve your metal away.
Oh, really?
Yes. Because just like your acid wants to dissolve and react with the iron when it's in the iron oxide form, it wants to interact with the iron when it's in pure elemental iron form. So acid, like vinegar, reacts with and rinses away rust, but if it's concentrated enough, it will also react with and dissolve part of your metal.
Wow. That's crazy. So don't go using some crazy strong acids on your pans.
Yeah, don't take your pool acid and pour it over your pan or your rusty nail or whatever it is, because it will just dissolve your pan away probably.
Gosh, that's so nuts. That's weird, dude.
Isn't it weird?
Obviously, we all know that about that's kind of an image I think people have about some acids because we've seen it in movies or something. But it is just kind of crazy to think this is a heavy piece of metal that I've got and that something can dissolve it away.
I know.
Even if it would take a long time or it took a lot of acid or whatever, it's just still kind of nuts.
It is kind of nuts. But it is also, I think, very interesting.
Yeah.
Okay, but there's more.
Whoa. There's a lot of tidbits here.
A lot of tidbits. So you can dissolve the iron oxide away, and you might dissolve some iron as well away. But you can run the reverse reaction and get iron, elemental iron, out of iron oxide.
Huh.
And there are some scientists who are doing it and watching, I think with an electron microscope, how that process works. But it takes a lot of energy, and it's not worth it to fix your rusty pans or whatever.
Yeah.
But you can do it. With a lot of energy, you can run the reverse reaction and get your iron back.
Huh. Interesting.
So that's possible.
That's crazy.
Oh, and there's one more fun fact I forgot to tell you about.
Please.
I just really got excited, clearly, as you can tell while I was doing this one. So the last fun fact is that sometimes soil looks reddish.
Mm-hmm.
You know that rusty, sandy soil color?
Yeah.
And that's because there's iron in the ground, and it oxidizes and forms that reddish color in soil.
Right. Because, like, if it is there, then it's pretty much definitely going to be around water.
Mm-hmm.
Interesting. So that's a lot of soils that are reddish, pretty much are going to have some amount of iron in them.
Yeah, and I found this really cool website from the United States Department of Agriculture that talks about the color of soil and all these different iron complexes that have different colors.
Huh.
So you can have iron that makes a yellow when it's mixed with certain things. You can have iron that makes dark red, that makes black. It could do all kinds of fun stuff. So soil color has a lot to do with the iron minerals that are in the ground.
Interesting. It's so weird to think of rust as not just the annoying thing that forms on stuff that we're trying to use that gets wet or whatever over time. It's just so weird to think of it as this part of everyday life that is also around us in other ways, like soil or whatever. It's just kind of like in this category of my mind, like old stuff, or a mistake you made, like leaving something out in the rain or whatever. It's like, it's just in that category so strongly. It's so weird to think of it as like, nah, it just happens. And they actually, at least the elements themselves are fine with it.
Mm-hmm.
And it's everywhere else. And it's not like bad or good or whatever. It's just is.
I know. Isn't that so crazy and cool?
Yeah, that is crazy.
So that's it. That's what I have for you.
Dude, nice. That was interesting.
It was so fun. It was fun researching it. Rust was a lot more multidimensional. I mean, I knew a lot of that from being in school, but I didn't really know all the different colors of soil, and I didn't know that the acid was dissolving away the rust and even sometimes the metal. I learned a lot. It was fun.
Dude, that's crazy. I also don't think I knew that vinegar could do a lot. I don't think I knew that you could just use that to get rust away.
Yeah, I don't know if it's always just easy as pie. I think maybe sometimes you have to soak it. I don't know, but it can do the job.
Dude, interesting. Rust.
Way to go, Rust. Keeping us honest since I don't know. I got nothing. I got no idea of how long Rust's been keeping us honest.
Thanks, Russ, for being a good analog for what a lot of friendships are like.
All right. Well, and on the note of friendship, do you have any happy things? Maybe did your friends make you happy this week?
That's not what my friends did. I mean, I guess my friends are always probably in some way making me happy and are definitely a very enjoyable part of life. But the thing I was going to share about for my week that was kind of cool was a work project that I've been doing that I've, for the most part, wrapped up as of today.
Woo!
And I'm just like pumped about it because it went really well. It's my first official project writing copy for web pages. And I haven't really had a project like this, but a guy was like, hey, could you do this, you think? And I was like, absolutely, I'll try and I'll do my best. And so I submitted all the copy I wrote for these pages today and got like very emphatically positive feedback on it. And there's just that feeling you get whenever you've done anything at all remotely took effort, especially something like new that you haven't really done very much of.
Right.
And that you basically just get told that you did a really good job. And it just like, there's not really a feeling like it.
Yeah. Right. It's just the satisfaction of the job well done.
Yes, exactly. Exactly. So that was a big highlight of my week this week. How about you?
I've kind of talked about my PhD program. So it consists of your classes and then taking these big exams, and then you write your dissertation. Mm-hmm. So I'm taking my big exams, and I've taken all the written ones, and then I have to propose a research idea and defend it. So that's called an oral qualifying exam, basically. I have to write up a proposal in the form of if I was going to submit it to be awarded money for a grant. And I hate it. And I am not really good at writing. Literally, while I was taking my exams at one point, I was like, I wish I could just learn all this information and then have a nice chat, which is what we do in the podcast, you know? So,
yeah.
So I'm just not good at writing. I'm not good at being motivated. And then I feel like I should be doing more, and it's just really hard. So that is where I've been.
Yeah.
But I got to 4 full pages of first draft writing as of yesterday.
Nice.
And I sent it to my advisor and said, this is not ready for edits, but I just wanted you to know that I am working and making progress.
Nice. Dude, that's great.
So that almost like your job well done feels like I have passed a milestone. I have started the hardest part. I've got first draft writing done, and now I have a product to shape and hopefully turn into something that means I can move past this roadblock. So,
dude, congrats. That's great. That's great news.
Congrats to you too. We had nice productivity moments this week. That's exciting. Error 5, virtual 5,
virtual
Zoom 5. Thanks for coming and learning about rest, and thanks to all of you listeners for indulging my several fun facts at the end and big excitement moments, because I had a lot of fun writing this episode.
Dude, thanks so much for teaching us. Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we want to hear from you. In fact, some of the best ideas have come from you guys. So if you have questions...
That's absolutely true.
Yeah. If you have questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share thoughts and ideas. If you enjoy this podcast, you can subscribe on your favorite podcast app. And if you really like it, you can write a review on Apple Podcasts. That helps us to be able to share chemistry with even more people. If you'd like to help us keep our show going and contribute to cover the costs of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee.
This episode of Chemistry for Life was created by Melissa Collini and Jim Robinson, and references for this episode can be found in our show notes or on our website. Jim Robinson is our producer, and we'd like to give a special thanks to A. Kiwasong and A. Hefner, who reviewed this episode.